All right, well, whoever's on here, my name's Anastasia Wiens. My project for 909 was siting nuclear power plants in the Western United States. So a little background, part of Biden's Green Plan was stepping away from using fossil fuels and utilizing more clean energy sources, and nuclear is one of those. This is due to nuclear not producing a lot of greenhouse gases, and nuclear can actually produce more power than other clean sources such as solar and wind. So the question for this project was, what areas in the Western United States are most suitable for siting nuclear power plants? So some criteria that was in review for this project were geological hazards such as volcanoes, landslides, faults, and significant earthquakes. Other items were current nuclear power plants. So only current nuclear power plants that are being utilized or reviewed that's in the study area are now lakes and rivers, and then city limits with large population densities of 500 persons per square mile. The study area is then divided into three categories as most suitable. So these areas will have no geological hazards, will not be near current nuclear power plants, will be within 2 miles of lakes and rivers, and then not in any large populated dense areas. Suitable areas are very similar to this, except they're not going to be close to water, and then not suitable will have all those hazards near nuclear power plants and within those large populated areas. The study area. So these are all the states that are in blue are in the study area. The reason Oregon and California are not part of the study area, even though they're in the Western United States, is due to these two states have regulations in place for not allowing any future siting of nuclear power plants. So the workflow. So everything was done using ArcGIS Pro. Over the study area, there was a fishnet created with the squares that were 50 acres in area. Within the study area, there was a 10-mile buffer between all the state borders due to regulations that states have. They might be different from each other in case there was a nuclear disaster to occur. And also they have different maintenance as well, regulations that branch off of the overall US regulations for nuclear power plants. Buffers were created for volcanoes, active faults, current nuclear power plants, as well as city limits. And then also the 50 acres were reviewed with the significant earthquake data. So any of those areas were considered not suitable, and then found areas that were within 2 miles of water. So more in depth in the data. So significant earthquakes. So these are all the earthquakes that have caused deaths or damages in the US that are in the study area. So if any of these earthquakes were in those 50 acre squares, they were deemed not suitable. Landslides. So these are landslides that are moderate to high susceptibility. They were reviewed. So anything below moderate was not considered as a danger. And so anything that was overlapping those 50 acre squares were also deemed not suitable. Active volcanoes. So these are all active volcanoes, and they're considered active as they had an eruption within the last 10,000 years. All volcanoes were treated the same, even though they're not all necessarily the same, but they all have a buffer of 30 miles to account for lava flows and ash fall. So anything that was within that 30-mile buffer was also not suitable. Active faults. So these are all faults that had an earthquake with a magnitude of 6 or higher, and they're all within the Quaternary period. A buffer of 10 miles is created. Again, not all faults are created equal. There are more regulations in place with the US nuclear regulations. There's measurement depending on how long a fault is. They'll have more further away the nuclear power plant needs to be. But for this project, all of them have a 10-mile buffer. So anything in that 10-mile buffer was considered not suitable. Current nuclear power plants. So there's only 2 nuclear power plants within the study area. It's one in Washington and one in Arizona. A 150-mile buffer was created just to have a spacing so that another nuclear power plant can't be right next to a current one. And as well as nuclear power plants are considered a man-related hazard, so you cannot have two nuclear power plants right next to each other in case there's failure of one. So anything in that buffer was not suitable. All right, water. So water is very important for nuclear power plants for cooling purposes. So that's why most nuclear power plants are built by oceans, lakes, and rivers. For this project, lakes and rivers were considered, and they had to have year-round water. They needed that large body of water for cooling purposes. So nuclear power plant, for it to be close to these, they need to be at least 2 miles away. So any areas that are 2 miles away from water were considered most suitable after removing all those hazards, current nuclear power plants, and population density. City limits. So these are all the city limits that have 500 persons per square mile or greater. So nuclear power plants can't be placed in a highly populated area, and they also have to be at least 20 miles away from these high populated areas. So a buffer 20 miles was created, and also nuclear power plant couldn't be within those city limits. So all those areas are off limits and were deemed not suitable. This is the resulting map after taking all that criteria into account. A lot of the study area was considered not suitable, but there are a few states that had more suitable areas, and these were Idaho, Montana, and Wyoming. This is probably due to the northern part of the study area had more natural water than a lot of the southern part. And then Nevada, Colorado, and Washington had more not suitable areas. This is probably because Nevada, looking back at the fault data, most of Nevada was covered in faults. So that really made Nevada not suitable. Colorado, again, looking back at the data, a lot of landslides cover the west half of the state. And so that made it not suitable. And then Washington, it has a current nuclear power plant that took account of most of the southern part of the state, but also there was a decent amount of volcanoes, and that's probably due to Washington sitting on that plate border of North American plate and the Pacific plate, which causes volcanoes in that area. All right, in terms of acreage, so most suitable, about 1.17% of the area was deemed most suitable. This was over 11 million acres. Suitable areas was about 22%, and this was over 213 million acres. And then most of the area was 76.38% was not suitable. So that was over 725 million acres. So conclusion, areas that were considered are categorized as suitable, they have potential and could be used instead of using natural water. Palo Verde is a really great example of this. It uses recycled water as its cooling source. I mean, it's in the desert, so it's not really next to a natural water source. It could be an option because even though the water is not totally wasted when it's using for cooling of nuclear power plants, it does go back into the water at a higher temperature, which can mess with ecosystems of the water. So it is an option and should not be totally ruled out. So the current power sources in this study area, it is something I wish I had looked back at the beginning, but in retrospect, there's a lot of states in this study area that still are heavy use on fossil fuels as their energy source. Some states use a mix of both renewable or clean energy sources, such as solar, wind, and hydro, but they also use coal and natural gas. Arizona is one of them. Even though we have a nuclear power plant, our power source isn't 100% Palo Verde. It is a mix of natural gas and some coal and hydro. So it'd be great to look more in what areas that could benefit using nuclear power plants and stepping away from using fossil fuels. Next step, so this was a really great starting point of finding potential areas for siting nuclear power plants. The most suitable and suitable areas would need further review of other man-related hazards, such as airports, military bases. Those all need to be avoided and have to be a certain distance away. Also protected areas. Protected areas, you don't want to place a nuclear power plant in a protected forest. That would be great. Also more in view of water. Power plant for cooling purposes, any natural or any disasters that might occur, it will help with preventing further damage if there's enough water. And population growth. So this is very important. This project just focused more on current population rather than looking at population growth. You don't want to place a nuclear power plant if there's a high decline of population. You want to place those nuclear power plants in places that are going to be growing in population, as they'll need that power source in the future. That's all I have. Thank you for listening to my presentation. Let me know if you have any questions.